I'm Jim Gennety with Building Services, and what I'd like to talk about today is how we affect other parts of the university by removing soils from buildings and what kind of impact that actually has on building systems. For instance, we use matting systems in the front of buildings, and the reason why we do that because matting systems are known to remove 85% of the particles that actually can enter the building. The reason why that's pretty important is the stuff that we're trying to trap in the mats are things that are very abrasive. They are abrasive towards the floor finishes, carpet, and other things in the building. The other thing that we do as far as removing soils from the building is that we use a vacuum system versus dust mopping. Dust mopping has a tendency to move soils from one place to another, versus the vacuum system actually vacuums up the soil and puts it in a bag that won't be released back into the building. What's so important about these things is, number one, it protects surfaces. The other thing that it has that's pretty important about it's important to know that it also helps in energy consumption. By removing the soil, we have more air can go through air handling systems and things like that. Plus, we can also save the life of filters. I saw a big impact on the filter systems of the air handling system. And when we went from replacing those on a monthly basis to a quarterly basis and then an annual basis, giant cost savings. And when we start seeing the fact that these plug filters cost a lot of money because air wasn't moving through there, so heating wasn't happening, cooling wasn't happening, and when that doesn't happen, you're running motors that it's not moving air, so it's a cost and with no benefit. The same with computers and things. It's the largest impact on computers and their longevity, but when we can take and remove the soil from the air, there's a lot less that gets onto the grates and the filters of a computer. I think it's just ambient air. What happens is the soil, once it gets into the building, it has a giant impact as far as how it gets throughout the building. Because as we walk on the floors, it happens to go up into the air. And it's not just the cleaning equipment that causes, this is everyday movement through the building. Anytime you have movement, the air is moving as well, and dust and those types of things move too. So the smaller dust has a tendency to go up and get caught in the air handling systems, our HVAC systems. Not necessarily. I think in the winter season what you're seeing is that we have an issue with ice melt. And ice melt, again, it's salt, which is an abrasive material. It really damages things like floor finishes and actually damages floor. We have an example of a building on campus that just put in a brand new $250,000 carpet that was being ruined by the salt, the ice melt. What was happening because of not a good matting system, the salt actually was brought into the building and left by people's footprints, and then the next person that walked over that picked that up and then actually moved it further in the building. And with melting of snow, you got a lot of moisture and liquid with that. And what happened with that as well was we started getting wet, salty type of buildup on carpets and things. It stained it, and when that salt is abrasive, but as it dried, it was actually like sandpaper on the carpet itself, which all carpet has a luster to it, which it actually sanded off the luster of the carpet, the fibers. So it made it dull and looked ugly. So within one season, just by not having a good matting system in that building, we had the potential of ruin and probably a quarter of that carpet. The other times that we see problems is throughout the year. We've had a wet summer. We've had a lot of stuff running down streets where all the gravel and dirt and stuff runs down the street. We've got piles of this stuff. People walk through those things. It gets caught on their feet, and without the matting, again, we get rough abrasive soil into our buildings. And when it's really dry, you got dust, and that has a tendency to again, come into the building with wind and those types of things. And when people are in buildings a lot and they're not outside, you're right, Michael, on the fact that we see some issues with that. Dust is made up of about 80% of pieces of people. Our dandruff, our hair, skin, those types of things. So that's another issue that we deal with as well. And the bad things about human type of dust, it has a tendency to decay and have an odor to it. So we want to get rid of those things. So all through the year we have some issues with removal of soils and stuff from our environment. One of the things about removing some of the soils from the laboratory situation, the soils can be mixed with biological, other kind of chemicals and things that are actually in the laboratories that fall on the floor, dry up, and now become a dust. Can mix with those types of things. We have a lot of animal research, and all the bedding and things that go along with that is another thing that can cause some things laboratory wise. But one of the biggest things I think with the laboratories is, again, we use a lot of refrigeration. I remember one of the first days that I was here in the campus, we were walking down a large corridor, walking down the corridor at BSRB, and it was lined on both sides of the corridor with all these refrigerators. These are very expensive medical type, research type of refrigerators for one thing. And as I'm walking down the corridor, each one of these refrigerators are built in a way that they're easy to maintain. They all had a filter on them for cooling on the bottom at the very front of it. And each and every one of these filters were completely plugged up because building services are told not to touch those things. But it's the dust that actually collected on those that, number one, it's very hard to keep them cool, the refrigeration cool. And even in the summer months, it also is consuming more energy because what's happening, the operation of the refrigerator itself is heat. So now we're trying to heat or cool things that we're also adding heat to it. And air wasn't moving through those things. What I've experienced in the past, by cleaning some of those things, I've seen about a 20% decrease in energy consumption in that particular one area, just by cleaning the refrigerators, the freezer, and some of those things that consume energy that require some kind of circulation around them. Anytime you can clean those coils, those filters and things is a big difference. We do not clean any of those filters, but the soil that came from that, once we started removing that soil from the floors and things, it has less of an impact on those filters. So what we're doing is removing it before it gets to those filters. Mm-hmm. Okay. And that's a pretty important thing. Electricity is energy, and energy creates heat. So, because if you have a plugged up filter and the air is not flowing through the cooling system of a refrigerator, what happens, that motor, that compressor runs for a longer period of time. And the longer it runs, the more heat that it actually adds to the ambient temperature on the inside of the building that we're trying to cool something with, because we're adding heat to it at the same time we're trying to cool something. So it's almost like it's working against itself. So when you remove the soil and the dust from the filter, it allows that to circulate a lot better. So those motors run a lot less time. And that's where the savings come from. These are big, expensive, high energy use refrigerators. And they require to have really good circulation around them. But as you walk down the hall, I noticed that every one of them were plugged up with soil, dust. So, just by the act of cleaning those off with a vacuum cleaner instead of brushing them off, because particles fall to the floor, and then they'll get back up there. What we're actually doing, cleaning, is the act of removing unwanted matter from your environment and putting it in its rightful place. Generally, most of the refrigeration is out in the corridors. They actually have corridors
That's right.
of refrigeration.
Right.
The other place that you would see this kind of thing happen too is in baseboard heating. The fin tubes on that baseboard heating gets filled up with dust, and now the circulation is not going through there. What happens is that fin tube actually is heating, but there's no air going past it to heat the room, so that stays on longer than it should. So just by the act of just removing that dust from fin tubes or any kind of filtration, the same thing with computers, any kind of electronic equipment, when you remove that and let the air move past it, it runs cooler and it takes a lot less electricity. Or in our case, whatever kind of fuel that they're using to heat water with, gas or something like that. So we do have a big impact on other building systems within campus. I mean, it's really, something that we should take a serious look at. So thank you very much for your time and have a great day.